Question 1. In the context of a rooftop package unit installed in a humid climate, technician Mr. Alvarez observes that the air being supplied into the building has a dew point close to the dry bulb temperature. Occupants complain of a clammy feeling despite the temperature being within the comfort zone. What is the most likely issue? A. The system is oversized, causing short cycling and inadequate latent heat removal. B. The TSV is underfeeding due to restricted sensing bulb. C. The evaporator coil is dirty, causing reduced heat exchange. D. The return air filter is excessively restrictive. Answer. Correct answer. A. Explanation. Oversized systems frequently cycle off before adequate moisture removal, latent heat removal occurs, leading to high relative humidity indoors. ASHRAE Standard 55 emphasizes both temperature and humidity in comfort. A dew point close to dry bulb indicates poor dehumidification. TSV restriction or dirty coils would lower capacity but not necessarily cause this humidity symptom. A restricted filter impacts airflow but typically increases static pressure and might reduce total capacity, not just latent control. Question 2. Throughout the course of routine services, Patel inspects a heat pump in heating mode and finds the outdoor coil partially frosted, although ambient temperature is only 45 deg. The defrost control is operational. What could be the underlying cause? A. Faulty reversing valve not fully seating in heating mode. B. Indoor blower motor running at incorrect speed. C. Malfunctioning outdoor fan motor causing low airflow across the coil. D. Undersized accumulator causing liquid refrigerant to bypass compressor. Answer. Correct answer. C. Explanation. At mild outdoor temperatures, frost should not accumulate unless the coil isn't receiving proper airflow. A failed outdoor fan motor would reduce airflow and encourage frost formation. Per manufacturer specifications and the ICAM Manual S guidance, airflow across outdoor coils is critical for heat rejection. The reversing valve issue would cause inadequate heating, not frost. Blower speed affects indoor performance. Accumulator protects the compressor but doesn't influence frost buildup unless refrigerant migration is extreme. Question 3. From a practical standpoint, why does a scroll compressor not require suction or discharge valves, unlike a reciprocating compressor? A. Scroll compressors use magnetic fields to control flow direction. B. Scroll geometry creates continuous compression, eliminating valve need. C. Scroll compressors operate only in variable speed applications. D. Scroll compressors incorporate internal spring-loaded check valves. Answer. Correct answer. B. Explanation. Scroll compressors compress refrigerant through orbiting scroll plates, allowing for nearly continuous and sealed compression with no need for suction or discharge valves. This design reduces moving parts and increases reliability. RE Standard 540 outlines these mechanical efficiencies. Reciprocating compressors need valves to control intake and exhaust strokes. Scrolls are commonly used in both fixed and variable speed systems, and while they may include check valves, they do not replace the suction discharge valve functions. Question 4. Given the circumstances of a system evacuation prior to refrigerant charging, Mr. Becker applies a vacuum pump and reaches 500 microns. After isolating the pump, the vacuum slowly rises to 1200 microns over 10 minutes. What is the best next action? A. Proceed with charging as the vacuum level is acceptable. B. Break the vacuum with nitrogen and repeat evacuation. C. Add a small amount of refrigerant to trace for leaks. D. Replace the vacuum gauge, assuming a calibration issue. Answer. Correct answer. B. Explanation. A rising micron level indicates the presence of moisture or a leak. According to EPA 608 best practices and ARCES guidelines, the vacuum should hold steady to confirm system integrity and dryness. Breaking the vacuum with dry nitrogen and repeating evacuation is standard procedure to remove moisture and non-condensables. Adding refrigerant prematurely is unsafe. Faulty gauges should be verified, but the symptom here points to moisture, not sensor error. Question 5. In what ways can the placement of a duct-mounted humidifier downstream of the evaporator coil in a residential HVAC system affect system performance? A. It may cause short cycling of the cooling system. B. It can introduce moisture to the supply air, improving latent capacity. C. It may increase corrosion in the supply duct and reduce IAC. D. It can overfeed humidity to the return plenum, decreasing static pressure. Answer. Correct answer. C. Explanation. Installing a humidifier downstream of the evaporator exposes the supply ductwork to continuous high humidity, which risks microbial growth, corrosion, and duct insulation damage. ASHRAE 62.1 warns about IAC risks from improper humidification. While moisture control is beneficial, humidifiers must be carefully positioned and controlled. It doesn't impact cooling cycling directly, nor would it decrease static pressure through return overfeed. Humidity is usually added to supply, not return air. Question 6. Taking into account the use of a pressure enthalpy diagram, how would a technician identify whether a system is experiencing flash gas at the metering device outlet? A. The refrigerant enthalpy will decrease at the evaporator outlet. B. The refrigerant pressure will sharply drop in the condenser. C. The enthalpy line will intersect with the saturated vapor line prematurely. D. The refrigerant temperature will rise at constant enthalpy during expansion. Answer. Correct answer. D. Explanation. During expansion, pressure drops while enthalpy remains constant, leading to partial vaporization. Flash gas. On the pH diagram, this is horizontal movement at constant enthalpy into the two-phase region. Flash gas reduces system efficiency as it occupies evaporator volume without contributing to cooling. Identifying this helps diagnose overfeeding or improper subcooling. Reference: HVACR Refrigerator Handbook and RE's pH diagram interpretation standards. Question 7. As a result of electrical troubleshooting, Hammond discovers that a single-phase compressor frequently trips the breaker during startup. She tests the run capacitor, which shows a 40% loss in capacitance. What is the most appropriate action? A. Rewire the compressor to a different contactor. B. Replace the capacitor with one of equal or slightly higher MFD rating. C. Install a hard start kit without replacing the capacitor. D. Replace the compressor since it is likely shorted. Answer. Correct answer. B. Explanation. A capacitor that has lost 40% capacitance cannot provide sufficient phase shift for startup torque, especially on PSC motors. Per NEMA and all standards, failed capacitors must be replaced with units of identical voltage and rated MFD. Installing a hard start without replacing the faulty capacitor only delays failure. Rewiring doesn't address root cause. Compressor replacement is unnecessary. Electrical tests confirm shorts. Question 8. When presented with a low-pressure refrigeration system using R123, technician is to green detects bubbles in the site glass during normal operation. What is the most likely cause? A. The system is properly charged and bubbles are normal for R123. B. The site glass is installed in a vertical orientation. C. There is a refrigerant undercharge causing partial vapor at the liquid line. D. The expansion valve is feeding too much refrigerant. Answer. Correct answer. C. Explanation. Bubbles in the site glass typically indicate flash gas due to undercharging or insufficient subcooling. This impairs metering device performance. R123 systems operate at low pressures, but site glass behavior is still diagnostic. The I guideline and EPA 608 type Roman requirements stress that liquid lines should deliver subcooled liquid to prevent flash gas. Orientation affects readability, not function. Overfeeding causes other symptoms: floodback, not site glass bubbles. Question 9. Based on the information from a maintenance inspection, Mr. Walsh observes a centrifugal fan in a commercial air handler producing excessive noise and vibration. Fan speed is within rated limits. What factor could be causing the issue? A. Motor is undersized for airflow rate. B. Shaft bearings are overlubricated. C. Fan wheel is imbalanced due to dirt accumulation. D. Static pressure is too low, causing overdelivery. Answer. Correct answer. C. Explanation. Dirt buildup on the blades creates imbalance and unbalanced rotational forces, leading to vibration and noise. According to SMACNA guidelines, fan balancing is critical to efficient, quiet operation. Motor sizing affects torque, not noise. Overlubrication typically causes overheating, not vibration. Low static pressure wouldn't cause mechanical vibration unless airflow rates exceeded design, which isn't indicated here. Question 10. The predominant theory suggests that improper brazing during line installation can result in what specific operational issue in a refrigeration system: A. Increased superheat due to line restriction from oxidation. B. Decreased subcooling from thermal expansion of lines. C. Intermittent short cycling due to low suction pressure. D. Compressor overheating from excessive oil migration. Answer. Correct answer: A. Explanation. Poor brazing without inert gas shielding, like nitrogen, leads to oxide flakes forming inside the line. These flakes accumulate in filters, screens, or metering devices, creating restrictions that reduce evaporator feed, thus increasing superheat. Per says and manufacturer guidelines, nitrogen purging is mandatory to prevent internal oxidation. Thermal expansion of lines is minimal in HVAC systems. Short cycling and oil migration are secondary symptoms, not primary issues from poor brazing. Question 11. When analyzing a heat pump system during the cooling season, Ramirez notices the indoor evaporator coil is frosting unevenly, with one side more heavily iced than the other. The system's TSV bulb is securely attached and the airflow is verified to be uniform. What is the most plausible cause of this issue? A. Partially blocked or kinked refrigerant line causing unequal refrigerant distribution. B. Failing reversing valve causing refrigerant flow reversal. C. Malfunctioning outdoor condenser fan motor reducing condensing pressure. D. Incorrect refrigerant charge causing excessive superheat. Answer. Correct answer: A. Explanation. Uneven frosting typically results from restricted refrigerant flow on one side of a coil, often due to a kinked or partially blocked liquid line feeding the TXB or coil. This causes refrigerant starvation in affected circuits, causing localized frosting. Reversing valve failure would affect heating-cooling modes overall, not uneven frosting. A bad condenser fan affects condensing pressure but not coil distribution. The correct charge affects overall frost patterns, but usually uniform. Question 12. Considering the electrical safety procedures for HVAC technicians, Lin is preparing to replace a compressor contactor on a live system. According to OSHA standards, what is the required first step before starting this task? A. Wear insulating gloves without shutting down the power. B. Verify the compressor is disconnected by unplugging it. C. Perform lockout LOTO on the disconnecting means. D. Notify the building occupants to evacuate before working. Answer. Correct answer: C. Explanation. OSHA 29 CFR 1910.147 mandates the use of lockout procedures to ensure energy isolation before any electrical work. This protects the technician from accidental energization. Wearing PPE without lockout is unsafe. Unplugging is not a sufficient or standard isolation method. Evacuations are unrelated to typical electrical work unless hazards extend. Equipped. Question 13. Given the circumstances of a refrigeration system using R400 TINA, technician Johnson notices the system's condenser pressure is abnormally high during peak summer hours and the unit shuts down on high pressure cutout. Which of the following is the most probable cause? A. Overcharged refrigerant causing elevated condensing pressure. B. Clogged condenser coil reducing heat rejection efficiency. C. 46V stuck open causing flooding in the evaporator. D. Low indoor airflow causing high evaporator temperature. Answer. Correct answer: B. Explanation. A clogged condenser coil reduces heat rejection, leading to increased condensing pressure and potential high-pressure trips. Overcharging typically causes high pressure, but usually combined with other symptoms. A stuck open floods the evaporator, but affects evaporator pressure, not condenser. Low indoor airflow primarily causes low evaporator performance, not condenser pressure spikes. Question 14. From the perspective of refrigerant handling regulations, Chen is evacuating a system for repair and notes a small leak in the refrigerant circuit. According to EPA Section 608, what is his legal obligation before releasing refrigerant into the atmosphere? A. Repair the leak immediately, but no mandatory recovery is required for small leaks. B. Recover refrigerant from the system and repair before any refrigerant release. C. Vent refrigerant outdoors away from occupied areas if the leak is under 10 pounds. D. Report the leak to the EPA and continue operating the system. Answer. Correct answer: B. Explanation. EPA Section 608 prohibits intentional release of refrigerants. All refrigerants must be recovered using approved equipment before repair, and no venting is allowed. Repairs must be made promptly to minimize leaks. Reporting is required for large leaks under Section 608 but not a substitute for recovery and repair. Venting is illegal regardless of leak size. Question 15. While examining a packaged rooftop air conditioning unit, Evans measures the static pressure across the supply duct system and finds it is significantly above the manufacturer's specifications. What potential issues might this cause to system operation and longevity? A. Excessive static pressure causes the blower motor to operate at higher amperage and risk premature failure. B. High static pressure improves airflow velocity, increasing overall system efficiency. C. Elevated static pressure leads to low return air temperatures and better cooling. D. Static pressure changes have no significant effect on compressor operation or system performance. Answer. Correct answer, A. Explanation. Excessive static pressure forces the blow-up motor to work harder, often increasing amperage draw, overheating, and reducing motor life. It can also reduce airflow, impairing cooling capacity. Manufacturer specs define max static pressure to avoid these effects. High static does not improve efficiency, it reduces it. Return air temperature is not directly impacted by static pressure but by system load and airflow. Question 16. In light of recent developments in refrigerant technology, technician Estonia is servicing system retrofitted from R22 to an HFO blend refrigerant. What is critical consideration when handling the new refrigerant compared to traditional refrigerants? A. HFO blends have identical lubricant compatibility and require no oil change. B. HFO blends are non-flammable and safe for all retrofit applications. C. HFO refrigerants often require polyester, PO and careful leak detection due to flammability. D. No change in charging procedures is necessary when switching to HFO blends. Answer. Correct answer, C. Explanation. HFO refrigerants often require synthetic PO oils for lubrication, which can absorb moisture aggressively and require meticulous leak detection since some blends are mildly flammable. Our classification. This impacts safety and service procedures. Not all HFOS are non-flammable, as some have flammability risks. Oil changes or additions are often necessary. Charging requires adjustments due to different pressure temperature properties. Question 17. Based on the information, Mr. Simmons is tasked with balancing the airflow in a multi-zone duct system using dampers. After adjustments, some zones have lower airflow than designed, while others are excessively high. What is the recommended approach to achieve proper balance? A. Fully open all dampers and increase blower speed to compensate. B. Adjust dampers incrementally, measuring static pressure and airflow at each zone. C. Close dampers on high airflow zones completely to force airflow to low zones. D. Install additional ductwork to increase overall system static pressure. Answer. Correct answer, B. Explanation. Proper balancing requires incremental damper adjustments combined with accurate airflow measurement, anemometers or flow hoods, and static pressure monitoring to ensure zones meet design criteria without causing excessive system resistance. Fully opening all dampers may overload the blower. Closing dampers completely starve zones. Adding ductwork is costly and generally a last resort. Question 18. When evaluating a refrigeration system experiencing low suction pressure and poor cooling, Stewart suspects a restriction in the liquid line. Which diagnostic tool and procedure is best suited to confirm this? A. Use a digital multimeter to check compressor winding resistance. B. Measure subcooling at the condenser outlet and compare to manufacturer specs. C. Perform a megameter insulation resistance test on wiring. D. Check evaporator coil temperature with an infrared thermometer. Answer. Correct answer, B. Explanation. Subcooling measurement indicates how well the condenser is rejecting heat and whether liquid refrigerant is reaching the metering device fully subcooled. Low subcooling suggests restriction or low refrigerant charge. Multimeters and megameters test electrical components, not fluid restrictions. Infrared thermometers show surface temperature but don't confirm liquid line blockages. Question 19. Considering the principles of psychrometrics, technician Mr. Allen is troubleshooting complaints of dry indoor air during winter. The HVAC system uses A steam humidifier connected to the supply plenum. Which factor is most critical to prevent overhumidification and potential condensation in the building envelope? A. Maintaining relative humidity below 50% at indoor temperature. B. Increasing steam output regardless of outside temperature. C. Reducing ventilation air exchange rates to conserve humidity. D. Using a manual timer to control the humidifier regardless of outdoor conditions. Answer. Correct answer. A. Explanation. ASHRAE Standard 62.1 and 55 recommend maintaining indoor relative humidity below 50% to prevent condensation on cold surfaces and mold growth. Overhumidification risks building envelope damage, especially in cold climates. Ventilation controls humidity levels but should not be reduced indiscriminately. Timers without sensor feedback often cause problems by over or underhumidifying. Question 20. During the commissioning of a variable refrigerant FO VRF system, Lopez finds inconsistent refrigerant pressures between indoor units operating at different loads. What is the fundamental design principle that allow VRF systems to manage varying loads effectively? A. Use of a single fixed speed compressor running at full load. B. Modulation of compressor capacity through variable speed drive based on demand. C. Multiple compressors cycling on-off in sequence without capacity modulation. D. Reliance on external heat exchangers to balance pressures mechanically. Answer. Correct answer. B. Explanation. ERF systems rely on variable speed compressors that modulate capacity precisely to meet varying indoor loads, optimizing efficiency and comfort. This capacity modulation is key to their performance and differs from traditional stage compressors. Multiple compressors cycling without modulation do not provide smooth load matching. External heat exchangers aid heat transfer but don't control capacity. Question 21. From the perspective of refrigerant recovery procedures, technician is working on a system charged with R134 that has a small refrigerant leak. She plans to recover the refrigerant before repairs. Which of the following best describes the required recovery steps according to EPIS Section 608? A. Recover refrigerant to the manufacturer's recommended level before opening the system. B. Recover refrigerant only if the system charge exceeds 5 pounds. C. Release refrigerant outdoors after recovery if the leak is small. D. Repair the leak first, then recover refrigerant after repairs. Answer. Correct answer. A. Explanation. EPA Section 608 mandates technicians must recover refrigerant to levels specified by the manufacturer or EPA-approved equipment before opening the system to prevent releases. Recovery is required regardless of leak size if the charge exceeds 5 pounds, but best practice is always to recover before opening. Venting refrigerants is illegal. Repairs before recovery are unsafe and contrary to regulation. Question 22. When evaluating the psychrometric conditions in a hospital HVAC system, Mr. Sanders observes that the air entering a critical care room has a dry bulb temperature of 72 degrees and wet bulb temperature of 55 degrees. What is the approximate relative humidity of this air? A. 35%, B. 45%, C. 55%, D. 65%. Answer. Correct answer. B. Explanation. Using a psychrometric chart, the combination of 72 degrees dry bulb and 55 degrees wet bulb corresponds approximately to 45% relative humidity. Accurate psychrometric analysis is critical in healthcare environments per ASHRAE Standard 170 to maintain infection control and comfort. The calculation involves comparing partial vapor pressures using dry and wet bulb readings. Question 23. Under the assumption that a split-system air conditioner is experiencing frequent compressor short cycling, which of the following would be the least likely cause? A. Oversized system relative to the cooling load. B. A clogged indoor air filter restricting airflow. C. Faulty thermostat with incorrect anticipator setting. D. Undersized refrigerant line causing low refrigerant flow. Answer. Correct answer. D. Explanation. Short cycling often results from oversizing airflow restrictions or fault controls causing premature shutoff. An undersized refrigerant line may reduce capacity but rarely causes short cycling by itself. Proper sizing and thermostat calibration per account manual S&T are essential for reliable operation. Restrictive filters reduce capacity and may cause compressor overheating, leading to short cycles. Question 24. In the context of brazing HVAC refrigerant lines, Mr. Hughes chooses not to use nitrogen purging. After completion, the system experiences intermittent restrictions and reduced cooling capacity. What is the primary reason nitrogen purging is critical during brazing? A. It provides a shield to prevent oxidation inside the pipe. B. It cools the tubing faster to avoid warping. C. It prevents moisture from entering the system. D. It adds pressure to check for leaks immediately. Answer. Correct answer. A. Explanation. Nitrogen purging displaces oxygen during brazing, preventing internal oxidation and formation of scale and silt inside the tubing, which can cause restrictions. The ASHRAE guidelines strongly recommend this to maintain system cleanliness and efficiency. Cooling and moisture prevention are secondary concerns, and leak testing is a separate step after brazing. Question 25. When faced with diagnosing a refrigeration compressor that hums but does not start, Kim measures the compressor windings and finds normal resistance but observes low starting capacitor capacitance. What is the most probable diagnosis? A. Compressor is mechanically seized and requires replacement. B. Starting capacitor failure leading to insufficient start torque. C. Defective relay preventing compressor energizing. D. Open overload protector causing compressor to trip. Answer. Correct answer. B. Explanation. A humming compressor with normal winding resistance and low starting capacitor capacitance typically indicates the capacitor is failing, causing insufficient starting torque. NEMA standards require capacitors to be within plus 5% of rated capacitance for reliable start. Mechanical seizure usually results in locked rotor or abnormal resistance. Relay or overload issues present different symptoms. Question 26. Demonstrated by an inspection report, Mr. Davis notes that a gas furnace's combustion air intake is located near an exhaust vent from dryer. What potential hazards does this setup create according to OSHA and NFPA 54 National Fuel Gas Code? A. Risk of flame rollout due to backdrafting. B. Contamination of combustion air with lint or moisture. C. Increased co-production due to incomplete combustion. D. Elevated risk of fire and carbon monoxide poisoning. Answer. Correct answer. D. Explanation. Locating combustion air intake near exhausts risks drawing back exhaust gases, causing carbon monoxide buildup and fire hazards. OSHA and NFPA 54 require combustion air to be sourced away from contaminants and exhaust vents to prevent toxic gas recirculation and fire. Flame rollout relates more to internal burner issues, and lint moisture contamination can clog but is less immediately hazardous. Question 27. By comparing different types of HVAC system metering devices, Mr. Patel notes that a thermostatic expansion valve provides what key operational advantage over a fixed orifice metering device. A. Eliminates the need for a receiver in the system. B. Maintains constant superheat under varying load conditions. C. Prevents compressor short cycling by adjusting refrigerant flow. D. Allows for operation without a liquid line filter dryer. Answer. Correct answer. B. Explanation. ESVS regulate refrigerant flow to maintain a constant superheat at the evaporator outlet, optimizing system performance under varying loads. This reduces flooding or starving of the evaporator. Fixed orifice devices cannot adjust flow, leading to less efficient performance. Receivers and filter dryers are generally still required regardless of metering device. Question 20. In what ways can improperly sized ductwork in a commercial HVAC system affect static pressure and airflow based on fundamental air distribution principles? A. Oversized ducts increase static pressure and reduce airflow velocity. B. Undersized ducts increase static pressure and reduce airflow volume. C. Properly sized ducts increase static pressure to improve efficiency. D. Duct size does not affect static pressure significantly in variable air volume systems. Answer. Correct answer. B. Explanation. Undersized ducts create excessive static pressure, which reduces airflow volume and stresses fans, impairing system performance. Oversized ducts reduce static pressure but may cause low velocity and noise issues. ASHRAE fundamentals highlight the need for correct duct sizing to balance pressure and velocity. Valve systems still depend on duct sizing for static pressure management. Question 29. During a service call, IS-NEWN finds that the heating boiler is cycling frequently despite the thermostat setting being stable. The system uses a low water cutoff control. What is the most likely cause of this behavior? A. Faulty thermostat causing rapid on-off signals. B. Boiler water temperature sensor malfunction. C. Insufficient water volume or air trapped in the system causing low water cutoff activation. D. Circulator pump running continuously without relay control. Answer. Correct answer, C. Explanation. Low water cutoff devices shut down the boiler when water level is unsafe, often due to air pockets or low water volume, causing frequent cycling. This protects the boiler but disrupts normal operation. Thermostat or temperature sensor issues cause different symptoms. Circulator operation doesn't usually cause cycling directly. Question 30. Considering the importance of PPE HVACR service, ISTA Torres arrives at a site where refrigerant leaks have been reported. Which combination of PPE should he done to ensure compliance with safety standards and minimize exposure risks? A. Safety glasses and leather gloves only. B. Respirator with appropriate cartridges, safety goggles, and insulated gloves. C. Flame-resistant clothing and steel-toed boots only. D. Earplugs and face shield only. Answer. Correct answer, B. Explanation. Handling refrigerants, especially during leaks, requires respiratory protection against inhalation, eye protection against splashes, and insulated gloves to prevent frostbite from cold refrigerant contact. OSHA and EPA recommend this PPE combination. Flame-resistant clothing and steel-toed boots may be necessary in some environments but don't address refrigerant hazards. Earplugs and face shields address other hazards.